Okay, so in this example, we're going to look at our one-to-one property dealing with natural logs. And so what I'd like to do first is I'm going to shrink this. We'll do these examples in a second, but we also did a few things where if I had 10 with just our regular common logs, log base 10 to the log base, 10 raised to the log base 10, 5. The idea was that because, and there's no base written here, so we know it's 10, the idea was because the base of the log and the base of the exponent are the same, it would reduce to what the log is of, 5. And so that same property holds true when we're dealing with e and its inverse, which is the natural log. So if we look at all these examples, we have e raised to the natural log. So the way the property works is, okay, well, what is that equal to? Well, if we convert the exponential form, log base e, I'm actually just going to write this as natural log of x is equal to natural log of 5. We have that same property that holds true. We have our one-to-one property. We have two logs on either side, so one log equal to another, so we can just say x is equal to 5. Well, the quick way to do it is cross that out. We see that we have an exponent and a log that have the same base, so they're going to cancel each other out. We're left with what the log is of. Okay, so this next example, this is slightly different. We have a coefficient in front of the natural log, so what we have to do is we need to remove that. Well, we have our power property, which means we're going to go ahead and raise this whole thing to the third power. We're going to apply our power property of exponents, so 5 times 3 is 15. And then because we have a natural log of base e, right, we have the same base, these guys are going to cancel out, and the solution is 15. So with our final example here in this video, I have an exponential function raised to the logarithm, or natural log, and so because the bases are the same, I can cancel these out. But before I cancel it out, this coefficient has to be brought up. So we're going to apply that power property, and we get the natural log and the e canceling out, and that would be 2 to the 4th. You can write it as 2 to the 4th, and that's sufficient. So these properties that we have dealt with natural logs are the same as with logarithms. So the simplification properties, the one-to-one property, all of those are exactly the same.